Hello everyone, new video, new kind of video. For sure we will continue the Kubernetes playlist, but today I want to change a little bit the kind of video, just to give you a feedback so regarding to my career. And right now I'm a site reliability engineer, so SRE, and I want today to look into how to choose a technology. So it's quite important in tech companies or in companies in general. But yes, don't hesitate to subscribe to the channel to not miss the next video. Like and comment this one if you want to support me. Let's go for this one. So the agenda today, the goal today it's to make like the journey about how to look into a technology, how to choose it, which steps do you have, and you can imagine that we are in a tech company. We need to find a solution. We have some needs, and we need to find a solution. And sometimes you just need to start like that, and you need to find one or some technologies just to solve your problem. And yes, you have multiple phases into this kind of journey. The first one will be to test something. That can be an official test like a POC, so point of convergence. That can be just a simple test, in fact, not really official, but you need to test a little bit the things before to ensure a production level. And this is this move that we want to discover today. So what is this journey? So usually in some companies where I worked, that was a big picture about that. That depends, of course, of the environment. So the global environment, the company where you work, that depends on the technology as well. So you need to mitigate or to just to change a little bit this scope to adapt it of your use case. Sorry, and yes, the first step will be the installation. So we will just discuss about that. The second step will be the configuration. The third step will be availability and reliability. So I am a SRE, so it's really important, subtopic. We have after that the observability, right after an important topic, so the security. It's important, but in fact, you need to deal with your needs. In fact, that depends of your company. Some company have a high level of security and high needs about security. Some other no. That depends, in fact. And the sixth step is the disaster. So meaning disaster recovery plan, of course, but some details into it. The seventh step is maintenances, not only one, but multiple maintenances, because we need to understand how to maintain a tool. So it's really important, in fact, because sometimes you can push a technology, but after that you could have some difficulties to maintain it, because that can generate some downtime and stuff like that. And the final step will be the internal knowledge. So really important topic to level up with an entire team, not only one person inside the team. Let's go. The first step. So installation. It's the first step and really first step. In fact, it's more to make a quick hello world to understand really faster how work a technology. And the hello world can be like nothing, in fact, but it's a first step, because if the hello world is like hard, that can mean it could be difficult to have or to maintain a production ready technology. Usually it's like that. that depends, of course. But yes, the hello world is the beginning of the things. And at this step, you can check the mode that you need to use, and the mode provided by the tool itself. Meaning that sometimes you have Open Container Initiative image, so Docker image, but globally an Open OCI image. Sometimes you need to deploy it inside a Kubernetes cluster, sometimes no. But if you need, can you just download an Helm chart, an official Helm chart maintained by the community, or you need maybe to develop your own Helm chart? That depends, but it's quite important because that means that you will have, or you need to integrate it inside your workload or regular workload to maintain a chart, to change the chart itself. And if not, maybe you have some so a package or multiple packages to just use or to maintain, like apt package for Debian with dpkg or stuff like that, or you have the same on Red Hat and so on. And this is the first contact, in fact, with the tool, with the technology. And don't forget that you need to find some challengers. At this step, never be focused only on one technology. You can imagine that you have multiple technology, for example, like in database engines, you could have like Postgres, MySQL, and so on. And you can imagine, for the hello world, you want to install multiple tools just to compare the first step and what features is provided by the tool. And at this step, you can already imagine the future, meaning that you can imagine the automation. Maybe at this step, like in Kubernetes with Helm chart, but with the GitOps like Flux or Argo CD, you can imagine, okay, that will be easy, or maybe it could be hard. This is the same thing with configuration as code or infra as code. Exactly the same thing you can imagine with Ansible, for example, to say, okay, to install this tool, there is a lot of tasks, a lot of dependencies and stuff like that, and it's not so easy. Maybe the challenger will be better, so the competitor will be better to automate it. Okay, so the second step now is the configuration. So we did the hello world, just a quick installation, but we need to be faster, in fact, and to do that, you need to well understand the tool. And classical things is config files and directories. So you can say, okay, but I use the OCI image. I don't need to have all details. In fact, it's not really true. It's a part of right, yes, but it's not totally true, because to well understand the tool and to deep dive a bit into it, you need to know where are a part of configuration files, which directories do we need to take care. So we have classical directories for the configuration, but we have data directories, for example, if it's a database engine, but like you can have like the same thing for static files and stuff like that. Just a dumb WordPress, you need to imagine to store the database, but you need to store the static files. We already saw that inside the Kubernetes playlist, in fact. So yes, a good question. Are there any data? Data is just a file, a single file or multiple file that I want to persist. And where I want to persist it, how to persist it, it's a really good question at the beginning. You don't really need to solve it right now at this step, but you will need to be sure to tackle this point further. So do we need to store something? It's really important, of course, in Kubernetes or outside of Kubernetes. This is a basic understanding. Which kind of system do we have? It's the beginning of the things. It's a distributed system or stuff like that. Through the configuration, you can already discover this thing outside of the classical documentation. You are in the terminal and you try to understand some stuff inside the terminal. The third step, it's more on the beginning of to be just to be focused for the production ready level. It's the availability and the reliability. So it's quite important, in fact, when you want to push something in production. And of course, you need to deal with your company needs and the developer team's needs and projects and so on. So it's not easy to well define this part and to just know which kind of options that you have. Maybe there is no option, so there is no need to challenge some things or to choose some things and discuss or just to deal with multiple teams. Maybe there is only one solution, so you can go directly into it, and that's straightforward, in fact. So how to ensure the high availability? Sometimes some tools are distributed, so it's quite easy. So that means that sometimes nodes nodes have the same value inside the cluster, but sometimes no. Like for example, if you just take Postgres, you have a primary and you have a slave, a follower, or multiple followers, and that means that you need to deal with that. Some tools like CNPG, operator inside Kubernetes does that really well, but sometimes you need to just deal with that, create your own tools, manage it by yourself, just monitor the cluster by yourself and stuff like that. It's not always easy, and sometimes it's just a distributed system. If we take like Elasticsearch or stuff like that, or Cassandra or ScyllaDB, you can directly add a new node, and finally, not sure that you need to have a different kind of nodes, and it's quite easy. In fact, when you have a cluster with 3 nodes, it's easy to have 5 nodes and so on. So yes, it's important to have it in mind and to deal with that, to be sure about the scope of the impact of the technology and what this technology can generate for the maintenance and for the reliability of the entire infrastructure. So it's important always to take a step back, to just first to be focused on the tool itself, and take a step back and check this tool, this feature, and this constraint inside your infrastructure and the impact for the entire infrastructure. It's really important. Which implementation in the infrastructure? Yes, this is what we said. It's which impact this choice can generate inside your infrastructure. Maybe you will add a single point of failure, so meaning a SPOF, or maybe you need to have a load balancer. So you need to create a new tool. Maybe you hadn't have it inside your so you hadn't this kind of a tool inside your infrastructure. So it's not really really easy. So you need to take a step back and just to understand this kind of stuff. Now the 4 step for the observability. Usually for observability, you need to have metrics, logs, traces. So this is three really important things, kind of data that you need to collect inside tools, and you need first to know maybe directly the tool can provide metrics, logs, and traces. Maybe the tool is compatible with the OpenTelemetry, maybe no. So you need to discover that. Is it easy to handle this data with your own observability stacks, maybe with Datadog or Grafana and so on? Do you have inside the community, do you have some dashboard or alert that you can reuse, even if it's not compatible? For example, you can imagine that for a tool like Cassandra, the community provides dashboards, and you can say, okay, but I use that Datadog, so it's not really useful. No, it's not really right. In fact, it's a little bit wrong, because you can just have a look inside the dashboard and try to figure out which data can be useful, and try to just re-implement that inside Datadog, just like that. Same thing for alerts that can provide you which kind of metrics are really important, which threshold, for example, where you need to take care to ensure a production level. And after that, the performance concerns is really important, because without observability, you can't really test a tool. Imagine like our previous examples on databases, you want to make like a classical benchmark. You can just create your own workload and try to push a lot on it, but if without observability, you can't check regular metrics on it, and you can't understand how it works, in fact. So you need to have this observability just to make a good POC and to understand how it works. Yes, it's really important. Of course, you have some classical metrics like latency, throughput, and so on. So you need to try to understand how works the tool to determine which of these metrics you need to take care in the test phase, and during the production phase. And after that, you need to determine the criticality about your technology. So inside the infrastructure, you can imagine it's a critical tool or not, and that will have an impact about the on-call process. Maybe you need to add it inside the on-call, and if you have an on-call process, you need to have like a runbook or process with documentation. So it's really important to try to create the documentation beforehand during the testing phase, just not in details, but just to keep it in mind, like a bullet point and stuff like that. So the 5 step. So it's the security, like I said, that depends a lot about a lot of things, like the environment of your company. That depends of the kind of infrastructure, maybe on-premise, or maybe in the cloud or mixed infrastructure. So that depends about a lot of things. The first thing is just take a step back, and you already check or figure out the observability things, so the criticality, and if the tool is critical inside your infrastructure. And it's a part, in fact, about the security. That means what happened if the tool is just in outage? What happened? And it's a part of the security. which impact that could have, and yes, it's really important. After that, you can again have a look inside your infrastructure to check out, or to check out the exposition of the tool inside the infrastructure. Some tools can be on the front inside the infrastructure, so you need to have a really high level of security, like a WAF, or like reverse proxy and stuff like that. So maybe you need to increase your security monitoring just to be sure to be sure to just monitor if there is some abnormal behaviors inside this part of the infrastructure, to be sure to not expose the rest of the infrastructure. So it's really important. The other part of the security is the information that you have. So maybe you have personal information inside, or you need to handle or to store personal information inside this technology. Maybe you have some secrets about the company, or some common secrets. And with that, you need to deal with that to ensure the right level about the security. Of course, on some tools, you need to deal with MTLS, TLS. You need to, maybe sometime you need to install SSO and stuff like that. So single sign-on tools to plug on your single sign-on tools that you have internally. So it's important to know if you can plug it or not, and to verify this point. And finally, yes, really important things, how to enforce, but how to test the security. Sometimes you just need to make just a classical internal test or audit, but sometimes you need to just contract with an external company dedicated to make a pen test, an external pen test, and so on. So yes, it's important to have it in mind. Now, the disaster. So when we say disaster, there is the backup and the restoration in the background, of course. But first, what is the disaster recovery plan? So how to recover if you have an issue. That can be a security issue, that can be just a classical issue because you dropped some data, or you lost the service, or you lost, I don't know, maybe servers or rack inside your data center. So how to activate your disaster recovery plan. So first, how to activate it, what is the escalation to be sure to communicate well inside the company, outside the company, what is the policies that you want to apply, which duration for the disaster recovery plan. So to do that, of course, you need to just write your process, and you need to ensure the test, and to know how many times to make this test. Okay, yes, you need to have a protocol, in fact. The other side of the disaster is the business continuity plan, in fact. So it's more about the business side, but yes, the boundaries are just short. But how long to ensure the business continuity plan? So that means how long to recover well for your customers. Maybe you can lose some data. So how many data that you can lose or not, and so on. And you need to define well the contract with your customers regarding about this technical part and technical decision as well. After that, technically, you need to have backup policies. So which frequency, the retention, The automation is really important, so you need to have a backup, but automating, so you need to automate the backups, of course, and to ensure that it run, it's good. You need to monitor it as well to be sure that the backup is done, and you need to test it. So this is the restoration part, but you need to have a process for the restoration and to have test on it. A backup without test is not just a backup. It's really important because maybe the D-Day, when you want, you have an outage, you want to restore, maybe your backup couldn't work, and it's just a nightmare when it's like that. And the restoration process is really important to be really smooth. In fact, when it's not a real outage, when you test it, you need to be really smooth, because when you will have a real outage, you will have a lot of pressure. So for sure, inside the company, probably managers will be on your arm and to check what you do. So it's better in this situation to have a process really well detailed. So meaning that with all commands into it, all steps, maybe the ETA about each step, to be sure if someone asks you something, you can just roll out your process and just check things easily and maintain a good level of communication. Ensure to not have a lot of stress or pressure, or mitigate that. So this is why it's important to have documentation and try to automate this process and test. It's really important because the D-Day, if it's totally so if you create the automation, it will be easy, in fact, and really so you will provide a really important value for your company in this case. The maintenance, it's really important. So I forgot the S here, but yes, it's really important. Just check out inside the community for your tool, your technology, which frequency for your upgrades or for this tool. It's important. So because if you have a lot of upgrades, you will need to ensure to upgrade with a high frequency, even if it could be easy with tools like Renovate and so on. But in fact, it's more job for your team. So take care about that. Have a look inside the GitHub repository to check the releases and the release frequency, and check the complexity. If there are a lot of breaking change and stuff like that, it's not really interesting, because you could have a downtime schedule or maintenance schedule that you need to communicate with your customer and so on. Is it complex or not? Of course. And could you, and at which level you could push your automation for the upgrade? It's really important. Process and concerns. Yes. Do you need to backups before the upgrade? It's important. Could you roll back easily? It's important as well. And do you need to schedule a downtime with a maintenance window? The duration about it. So is it short? Is it long? And the scheduling, of course. And now the final step, and the last but not the least, but not least, in fact, the knowledge is your goal. In fact, a person inside the team works hard on the technology, the tool, and you need to capitalize on it, just to level up together. In fact, across the team, it's important. Of course, You don't need to share all things that you discover inside the technology test, but it's important to give feedback, and a real feedback, in fact, not just a one-pager with a lot of details and concept, but just explain what is your sentiment about this technology, where are difficulties and stuff like that. And it's really good if you can do training sessions, even if it's a high-level discovery, but it's important to do that. Of course, the documentation is really interesting, and don't forget, there is now some AI agent about the code and so on. So try to handle the documentation and to provide a good documentation for your team and for AI agent. That means that you can provide into it examples or snippets about code and so on, just to be sure that if an AI agent can write a part of the configuration, it's easy to understand, and you can be really specific to your company usage about this tool. And don't hesitate to verify or to verify your process by like a beginner inside your team or outside your team. Take a developer, for example, if you are a sysadmin or SRE, take a developer and test with it to explain the tool, or to just make like a workshop with him. It's really important for you and for the company, because you will improve the knowledge about this tool, and you can with this kind of behavior, you can just ensure that the tool will be really well adopted inside your company, and it's the moment to do that. That's it for today. So go to production now, and don't hesitate to subscribe to the channel to not miss the next video. Like and comment this one to support me. See you in the next one. Bye bye.